Well, 7th grade, Mr. Hahn here, coming to you with the best of mathematics for the 7th grader. Ladies and gentlemen, we are going to spend the next 35 riveting minutes of your time going over that pretest so you have some sort of idea how this whole test is going to go. So I'm absolutely sure that you are going to want to take down some notes and see how things go here because everybody is happy. So here we go. Let's start right at the very beginning with some fun and excitement with problem number 1 here. I wish I had like all the answers for you for problem number 1 here, but I will tell you when it comes to time, there's really no easy way to do it. Maybe you can do it a different way, but this is what Mr. Hahn would do. We are going from 8:45 p.m., which is night, and going all the way to 6:35 in the morning. So here is the deal that I would do. I would keep track of both my hours and my minutes, okay, like this. Well, first of all, I kind of want to get to an even hour, so I'm going to add 15 minutes to this and make it to 9 o'clock at night. So I'm going to put 15, chalk 15 in my minute column over here. Then I'm going to get to midnight, which is 12 o'clock at night. So that's 3 hours in my hours. Then I need to go from midnight to 6 o'clock in the morning, which is another 6 hours. So now I have a total of 9 hours. But I don't stop there because I have to get to 6:35, so I need to add 35 more minutes to my minutes, therefore giving me 9 complete hours, plus if I put those together, I get another 50 minutes. Maybe you have a better way to do it, but time, just because of the way it's designed, it is not an easy thing to deal with. It's not based on 10, so our number system doesn't work the best with it. So blah, 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 blah. Problem number 2, boys and girls. Problem number 2, the number of pages in a chapter book are listed below. Find the mode and the median, ladies and gentlemen. You really, before you do this problem, you want to arrange from least to greatest. Okay, we really want to do that. So you're going to have to start. We have 1, 2 11s. Hopefully I leave myself enough room here. 2 11s, we have 1, 2, 3, looks like 4 12s. 1, 2, 3, yeah, maybe I should write a 12 there. 3 and 4. We have 1, 2 13s. We have 1, 2 14s. Oh, we have 3 14s. Sorry about that. See, that's why we cross them off so we can see 1 15 and 1 16. So there we go. Now that we've done that, finding the mode is easy. Mode is the thing that happens the most, the number that appears the most. And here you'll see that we have 4 12s. So my mode is 12. And the median, which is the real reason we had to do this, median means middle. I have to find the middle number in this group of numbers. So I need to know how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 13. The middle of 13 is the 7th number. 1, 2, 3, 4, 5, 6, 7. It's the 7th number because there are 6 numbers on this side and 6 numbers on that side. So my median is lucky number 13. There's my mode. There's my median. Problem number 3, we're looking for the sample space of a coin that is flipped 3 times. Okay, and the best way to do this, just to keep straight, would maybe be, sample space means all the possible combinations. And the best way maybe to do that is to kind of do a tree diagram that looks like this. Okay, so we've got our first flip. First flip, you can either get a head or you can get a tail. Notice the space I left there. After the first flip, on your second flip, off of each one of these, you could also get a head or a tail. That's on my second flip. Okay, so which means this. We'll stop here just for a moment so I can explain this. Here are my combinations. If I'm flipping a coin twice, I can get a head here and then a head here, so I'd get two heads. Or I could get a head first and a tail second. That'd be a head-tail. Or I can start with a tail and then get a head, or I can start with a tail and get another tail. But the problem is we have to do one more flip. And on the third flip, after each one of these, I can also get either a head or a tail. 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 Now, the way that this whole thing gets you your sample space is this. So I need now to list these. And I wish I had some more space. Maybe I'll move this up. I'm going to erase this little piece over here. If I can get rid of it. There we go. And I'm going to move this up so you can see here. I accidentally erased a head here, I think. So here's how you get your sample space. And usually sample space is a set of numbers. So I make this little brace, shows my set of numbers, and it goes like this. The first choice I have is a head, and a head. I could get 3 heads in a row. Or I follow this down, I can go head, head, tail. Or I start here, I can get a head, a tail, and another head. Head, tail, another head. Or I can go head, tail, tail. Wish my writing was better, so I apologize for that. So that takes care of this whole tree right here. Now I got to go and I start with the tail first. I can go tail, head, head. I can go tail, head, tail. I can go tail, tail, head. And I can go tail, tail, tail. Those, ladies and gentlemen, sample space means all the combination, and right there I have listed all of my combinations. There are 8 of them, and they're made by that little tree there. So problem number 4, you have to get 3 right to get 4 right. It said if that coin is flipped 3 times, which is what we did, what's the probability of getting heads at least twice? So the probability of getting at least 2 heads. Well, we know from our little sample space that I have 8 combinations, and I want to know how many give me at least 2 heads. At least 2 heads. Well, this one has at least 2 heads. This one has at least 2 heads. This one has at least 2 heads. And this one has at least 2 heads. All the rest of them only have 1 heads or no heads. So that ended up being 4 of the 8 things in my thing, which reduces down to 1/2. I have a 1/2 probability that when I flip a coin 3 times, I will get at least 2 heads. Question number 5. A 50-question test contains 20 true or false questions. The rest are multiple choice. What is the ratio of true or false to multiple choice? So let's do this. Let's write this down here. Okay, I have 20 true and false questions. I'm just writing down information. I have 20 true and false questions. I have 50 total questions. And that means if the rest are multiple choice, if I have 20 true and false and 50 total, and the rest, there are 30 left over, because 20 plus 30 gives me 50, that has to be my multiple choice. So this is the information I know. Now here's what you must do here. Ratio is nothing more than a fraction. And what is my fraction of? It is true and false questions over, first one listed, multiple choice questions, second one listed. So I know this. I have 20 true and false questions, and I have 30 multiple choice questions. This is my ratio. I just need to reduce it, divide them both by 10, and I get 2/3, or 2 to 3, we would say in ratio form, but it is 2/3. Okay, so please, 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 problem number 5 is a question. It's pretty simple, but you got to answer the question they ask, not the question you think they're asking, because a lot of you would probably put 20 over 50 or 30 over 50, but that's not the ratio that they were asking. Here we go. We're well on our way. Another ratio problem. Yes, I love ratio problems. The ratio of flour to sugar in the banana recipe was 3 to 2. If 3 cups of sugar are used, then how many cups of flour are needed? So here again, we know that there are, this would mean we need to draw a ratio box. And notice we learned about totals in our ratio boxes, but this doesn't give us a total. This is just a simple ratio box. The ratio, actual, I'm comparing flour to sugar. It is flour to sugar is 3 flour to 2 sugar. If 3 cups of sugar, 3 cups of sugar are needed, how many cups of flour? Now you will notice, ladies and gentlemen, that this does not work out evenly or nicely. Okay, because the first thing you do, remember, this is like having equal fractions. 3/2, 3 over 2 has to equal what number over 3? And that you can't. 2 times what is 3? Most of you can't figure that out by doing that. So this is that place where we need to use cross products, which means you take the diagonals and set them equal to each other, which is not that hard. 2 times what number equals 3 times 3? And 3 times 3 is 9. 2 times what number is 9? To figure that out, you do the opposite of this, solving equations. I divide by 2, divide by 2, and that's my answer. 9 divided by 2 is 4 1/2. You would need 4 1/2 cups of flour if you're following that recipe. Problem number 7, Ricardo drove 15 miles in 20 minutes. What was his miles an hour? Again, ladies and gentlemen, this is a ratio problem. We can solve it just like we did the last problem, except this one is pretty easy. Okay, what was my ratio? What am I comparing? I am comparing miles to hours. Actually, this gives it to us in minutes, so we'll just do that first. Miles, minutes, and miles. We are doing 15 miles in 20 minutes. But this doesn't ask me for 20 minutes, it asks me for hour. Hopefully you know how many minutes are in an hour. An hour is 60 minutes. So I put my 60 down here. And then I just need to say, okay, how do I go from 20 to 60? Multiply by 3. Multiply the top by 3. And you end up with this number here. This is how many miles per 1 hour. So 45 mph. 45 miles per hour. Question number 8. Printed on 1 gallon milk bottle was the measure of 3.78 liters. How many liters is a half a gallon of milk? A half a gallon of milk. Well, if we draw pictures, this really should not be that hard for you. Take a look. This is 1 gallon. And 1 gallon is 3.78 liters. I don't want a gallon. I only want a half a gallon. So basically, I just do this. If I cut this gallon in half, how many liters do I have? You just have to cut this number in half as well. Divide 3.78 by 2. You want a half a gallon, which is half of this number, which is what a gallon is. So bring my decimal up, put a 1, divide by 2, bring down 8 is 16, down. 2 goes into 18 9 times. So 1.89 liters is a half of a gallon. Question number 9, you know what? We are just going to skip. We are going to skip that. We'll talk rotational symmetry before. I don't think we talked about that, so let's just ignore that and hope it goes away for right now. Maybe we'll talk about it in a little bit. Although I thought I walked in and Mrs. Stone was talking about rotational symmetry, but that might have been 8th grade. Number 10, during the holiday sale, the store discounted all items 1/3. What is the discount on a 1995 item? So basically, ladies and gentlemen, you want a third of 1995. This is a 6th grade problem. We draw our little rectangle that stands for $19.95. I just want a third of it, which means I am cutting 1995 into 3 equal pieces. Bring up my decimal. 3 goes into 19 6 times, which is 18. 3 goes into 19 another 6 times, which is 18. Subtract. 3 goes into 15 5 times. The discount is $6.65. Voila. Problem number 11 and 12, ladies and gentlemen, you really, and you can have these, you should have these in your notes. They're both relatively easy. Let's just do them kind of both at the same time. The circumference of a circle, circumference equals pi times diameter, and area of a circle equals pi times the radius. And they said to use this for my pi, 3.14, and all the information we need is right here. So circumference is going to equal 3.14. We'll put that in parentheses just because. What is the diameter? Well, this 10 is the radius. So the diameter is twice that. The diameter is 20. So to find the circumference of my circle, I'm just taking 3.14, multiplying it by 20. Bring down my 0, 8, 2, 6. Count decimal places. This has 2 in it. This has none. So I come back 2 places, and my circumference is 62.8 centimeters. I can leave off that extra 0. Not needed. For the second one, area, same thing. 3.14 for pi. Radius was given there. It's times 10 times 10. And ladies and gentlemen, this is mental math because we've talked about this before. We would do this first. 10 times 10 is 100. And when you multiply 3.14 times 100, 2 zeros, 2 decimal places. Your answer is simply 314. And the label for area is centimeters squared. Ooh, that is something special. Problem 13, again, is a area problem. We don't have the formula for the area of a trapezoid just yet. We'll get to that. So you need to divide and conquer. I will redraw it for you just because you should redraw it for yourself. Boom, here's my area. 6, 8, 12. These are right angles. How am I going to cut this? I am going to cut this into a rectangle right here and a triangle right here. So area of the rectangle is simply 6 times 8. Please don't use 12 because 12 goes all the way across and the rectangle stops right here. So that's why we would use 8. 6 times 8 is 48. That's the area of the rectangle. And hopefully by now you're picking up that the area of a triangle is 1/2 base times height. Here are my 2 right angles. I need to multiply this times this and take 1/2 of it. So what is my base? What is this distance from right to here? Well, again, it's not 12 because it stops right here. If this piece was 8, 8 plus what gives me 12? That is 4. That's my base. And my height is this distance from here to here, which is, again, the same 6 as this. So it doesn't matter how you multiply here. 1/2 of 4 is 2, and 2 times 6 is 12. So the triangle is 12. Combining those together, 48 plus 12 would be 60 inches squared. 60 inches squared. Problem number 14, ladies and gentlemen, it says to solve by inverse operations. Inverse means opposite. We talked about this. This says 0.8 times x. Anytime a number is next to a letter, it's multiplication, equals 1.2. So how do I solve this? The opposite of multiplying is dividing. I divide by 0.8. And that's where you must remember and look at your notes about dividing by decimals. If you have a decimal out here in the divisor, you need to move that so that it's not there. I moved this one place, so I move this one place. Over, over, then I put it up here. And now it's 8 into 12. 8 goes into 12 once. And 8 goes into 45 times. So my answer for this is x equaling 1.5. Whew. We are just cranking right along. Here we go. Always got to throw in some adding and subtracting integers. And if you struggle with this, you really, really need to pull out your notes and look at them. Starting with this first, we're subtracting integers, and your notes say when you subtract an integer, you add its opposite. So now I've made this into an addition problem. What is a -3 plus a +2? And when you add integers, if they have opposite signs, you subtract them and keep the sign of the bigger one. So a -3 plus a +2 is -1. And then to that -1, I am now adding a -4. If that helps you to put this in parentheses, feel free. If you look at your notes under adding integers, it says if we add integers that have the same sign, you add those numbers together and you keep the sign of what they were. If I have a -1 and I add 4 more negatives to it, I get 5 negatives or -5. Now don't let that confuse you with problem number 16. This is multiplying and dividing. Okay, whole separate set of rules. Whole separate set of rules. And you must do the top first, and then do the bottom, and then do the division part here. So the first thing I'm going to do is look at this top. 2 negatives, if you look in your notes, if you multiply 2 numbers together that have the same sign, the answer is always positive. So I end up with a +12 there. And then I still have this -2 on the bottom. Now, when I divide, if they have opposite signs, my answer is negative, and 12 divided by 2 is 6. So my answer for that is a -6. Problem number 17, if you go wrong with that, you probably did not follow order of operations. Order of operations say you must do multiplication first, so I have to do this part of the problem before I subtract it from 7, 6. So when I multiply fractions together, if one is a mixed number, I must make it improper. And that means I multiply 1 times 3 and add the top. I get 4/3. Notice I'm not dividing, so I don't flip and multiply. I just multiply them straight across. And this is lovely because watch what happens. I multiply across, I end up with 12 over 12, which is the same thing as 1. So this whole thing ends up being 1. So what is 7/6 minus 1? Well, as Mr. Hahn has always said, write them up and down. 7/6 minus 1. Well, I change 1 to a fraction. I'm going to make 1 6/6. What is 7/6 minus 6/6? Simply 1/6. That is my answer for that. 1/6. Here we go. There's a lot of things to jot notes down on this The two parts where most people, well, everybody has trouble with all of these, I guess, but let's talk about it. Order of operations say I have to do exponents first. Please understand that 1 to the 4th power is not 4. 1 times 1 times 1 times 1 is simply 1. 2 to the 3rd power is not 6. It is 3 2's multiplied, which is 2 times 2 is 4 times 2 is 8. 3 to the 2nd power, same thing, is 3 times 3, which is 9. Anything to the 1st power is itself. And anything to the 0 power is 1. It doesn't matter what it is. So getting rid of all those exponents, that's what you get. And then you must work from left to right. 1 plus 8 is 9. 9 plus 9 is 18. 18 plus 4 is 22. And 22 plus 1 is 23. So far, so good, ladies and gentlemen. Two more, two of the easiest ones. Problem number 19 is a lot like that other problem we had. We have to do the top first. You got to do the subtracting first. And then you have to simplify the bottom first. And then the last thing you're going to do is do the division part of that, because it's this divided by this. So 2.48 minus 1, decimal goes after the 1, gives you 1.48 on the top of the fraction up here. 2 times 0.2, you get 4, 1 decimal place, which means you get 0.4. And then this is 1.48 divided by 0.4. 1.48 divided by 0.4. You're not allowed to keep this decimal here, so you have to go over and over and up. How many times is 4 going to 14.8? Well, this is 3, 12, and then 4 goes in 28, 7 times. So this whole thing ends up being 3.7. 3.7. And then last but not least, let us look at this one. 9xy. So this, you just simply have to do this. The number part, 9 goes into 36 4 times. Looking at x squared as being x times x. You cross off 1x with 1x. That leaves you with an x on top. Y cubed means you have 3 y's times themselves. And one of those y's will cross off with one of the y's on the bottom. You're left with 2 y's, so it's y squared. 4x y squared. And that, 7th graders, is how we do it. Now, if that didn't just excite you to no end, I don't know really what will. I'll give you a chance tomorrow morning before you take the test if you have any more questions about some of that. But again, I strongly recommend, maybe you want to watch this all over again tonight. You want to jot down notes, but you will be able to use a sheet of notes. As always, good studying.